Hi everyone, welcome to this OpenCV tutorial with Python for computer vision. This is the first episode, load your first images. And in this video, I'm gonna cover the following topics. First, we're gonna introduce what is OpenCV. Second, we're gonna go through the installation and the configuration of the environment to get you started. Then we're gonna briefly discuss about what is the images in the computer's perspective. And based on that, we're gonna create the images with NumPy array. And in the end, we're gonna load your first images with OpenCV. So for those who are new here, my name is Neo and I am a master student of AI located in Leuven, Belgium. I'm making this kind of video to help people understand more about AI as well as enhance my knowledge and skills. So don't forget to like this video and subscribe to my channel if you want to see more content like this. So without further ado, let's get started. So first, we're gonna discuss what is OpenCV. OpenCV stands for Open Source Computer Vision Library. It has more than 2,500 optimized algorithms for image processing, and mainly they support real-time image processing. It is written in C++, but it can be binding with Python, Java, and MATLAB. It can run in both desktop and mobile platforms, such as Windows, Mac OS, Linux, Android, and iOS. That's the reason why OpenCV is very popular. So, the first step to get you started with OpenCV is to install Anaconda. So you want to go here to the anaconda.org and you just directly go to the download pages and you want to click download here. And Anaconda provides an installer for all kinds of platforms. So here you can, based on your operating OS and also the bits of your machine, you can select the one that suits your. For me, I was running Windows and I'm having a 64 bits, so I'm just gonna click that. So now I have already downloaded the installer. Just double click and run it. During the running of the wizard, you don't have to really pay attention to anything. Just go for the default setting. Just keep on hitting the next button and finish the install. So after you successfully install Anaconda, you should be able to run the Anaconda. So you should be able to run the Anaconda navigator. So you will be able to see something like this. If you just freshly install the Anaconda, you need to create a virtual environment which will install the Python, and the OpenCV. So I already have created my own environment already here, but I'm gonna quickly show you how to create a new one. So normally after you install Anaconda, you should have this base root. From here, you want to launch the CMD prompt. So now I'm gonna show you how to create a new virtual environment. Just type conda create --name, and now we're gonna name our virtual environment. So let's go with new CV. And we're gonna install Python 3.7 here. And that's it. So now just hit the enter and let it run. So after you create your environment, you want to activate it so that later we can use it. So just go ahead with conda activate new CV. Hit the enter button, and now the new environment is activated. So after you have activated your new environment, you should be able to run Python. But however, before we do that, let's install another IDE which we're gonna use for the later part. So the IDE we're gonna use is called Spider. So let's install that. So conda install Spider. And let's see. So now we see that the Spider IDE has been installed, so we can directly launch this. So now we have launched the Spider IDE, and you can see that on the left part of this interface is where you write your Python code. And there's one interesting feature of this IDE which is here, the variable explorer. It is very helpful because we can see the type and the value of the variable of our program, and we can just check it. So on the bottom right side, you can see the Python console where you can directly run the Python code. Now let's just quick check if the Python can be run or not. So let's just print hello world. You can hit the F5 to just quickly run this code. So now we are seeing that this is output. So the Python is installed. So what is the images according to a computer? Let's start with the most simple one, which is the grayscale images. So each grayscale images can be represented as an array, and how dark a pixel should be can be represented as a value between 0 and 1. And when it comes to the color images, it can be represented as a combination of red, green, and blue scale images. So, as we discussed, a grayscale images is essentially an array of values. So we can actually start creating images by just building some arrays. So let's give you a quick example here. In Python, normally we use NumPy for all kinds of arrays operations. So let's first import NumPy as np, and let's start to build an array which is full of 0. So array 0, and here we're gonna use a function called NumPy0, so which will help us to create an arrays of 0. So here we're gonna use 0. Here we need to define the dimension of the array. So we're gonna go for, let's say, 100. So if you just run this, so in the variable explorer, which I just discussed before, you will be seeing that the name of this variable here, and if you double click on this, you will be seeing the array of a dimension of 100 times 100, and with its value equals to 0. Let's try to show what does this looks like in the image. For this, we need to import another library, which is matplotlib. Import it, pyplot splt. So this is a very useful library for visualize things. So now here, let's use the ELT show, and let's array 0. And here we want to map it to the grayscale. So let's gonna say map and the gray here. Alright, let's try to run this. Okay, there's a syntax, so import, this is from, this one should be from, and let's try to run this again. So now you should be able to see an image which has the width and the length of 100, and it's completely black. So let's try to create the same dimensional array but with different values. So let's create an array of 100 of its value. So here you want to go for np once, which is create a dimension of its value which is 1. So here we're gonna again go for 100, and let's go type 100 times this, so that we make sure that the arrow in the array is 100. The values in the array is 100. So let's do another one, which is 200. which is exactly the same here. So 400 times MP1s, and here inside 100, 100. Okay. So let's just do a quick pick here. So what if I just want to show this 100, and let's see what we got. Okay. Okay, let's run this. So here, after we run this, in the variable explorer, you can see that this one is all its values is inside of the array is 100, and this one is also 200. But here, we didn't actually see, we still are seeing black images here. There's no difference. And now let's try to horizontally stack them together so that we can see the difference between those three block images. So what you're gonna do here is to use this function called mph, which stands for horizontal stack, and you're gonna put these three arrays inside of here. So array 100, arrays 200. So they stacked it there. So we're gonna call this the stacked array. So let's see what does this stacked arrays looks like. So stack array here. So let's try to run this. So there we go. We get images of those three squares horizontally stacked together. So the black one, which is has the value of 0, and the gray one here is having the value of 100, and the white one here which is having the value of 200. Okay, now let's come to the final part of this video, which is to load the images on your computer with OpenCV. So what you're gonna do here is we need to import the OpenCV library. So import CV2 here. And let's just comment out on this. So you can use the hotkey of Ctrl+1 to quickly comment the code. So what are you going to do here? Let's say images equals to CV2 on rate. And here you want to enter the path to that image that you are trying to read. And here we need to show these images. Okay, so what you're gonna do here, let's try the plt im show, and let's go with images and the CMap. Let's try to run this to see what happened. So here you will see the images, but actually here it's very different from what I was seeing here directly from my PC. This is because the PLT and the CV2, they are using different ways of coding of the images. So here you don't want to use this PLT. If you want to use it, you need to do a BGR to RBG conversion. So instead of using the PLT, you want to use the CV2 im rate. So what you're gonna do here is you need to give a name of the window that you want to open. So let's say first images, and using the images we just read here. Okay, let's try to run this and to see if this will work or not. And it's stuck here. So we don't want to actually do this. We're gonna quickly improve this code. So what we're gonna do here is using while true. Okay, and here we're gonna show this images. The im show is gonna actually open a window for showing the images. What we are trying to do here is like when the window of the images shows up, and after that when we press the exit key for at least 1 millisecond, then we will close that window and shut down the program. Okay, so here also CV2 destroy all window here, So let's try to run this and see what result we get. So let's run this. And we get this image correctly with the same color. And now if we hit the exit buttons, then it will close and also our program will stop as well. That concludes this video. In the coming video, we are gonna look at more image processing methods such as filtering, smoothing, and so on. So if you have any problem, please feel free to comment, and I will try to help you as much as possible. If you like this video, please hit the like button and subscribe to my channel, and I will see you in the next one. Bye bye.